Hello, everyone, and welcome back to Perceive 2021. I have the honor and privilege of presenting myself. Hello, I'm Trey Pierce, and I will be your host today. I am a senior product manager here at Clarifai, and we are going to be talking about the exciting topic of workflows and how they can enable advanced use cases for AI. Quick look at the agenda. We're going to talk a little bit about flexibility and how that pertains to ML models, a bit about some of the common AI deployment pitfalls that we see, and how we can add flexibility and avoid some of those pitfalls by using workflows. We'll then actually talk about what is a workflow and the anatomy of one. We'll then look at, I'll walk you through very briefly how to put one of them together inside the platform, and I'll leave you with a quick teaser about maybe some things that are yet to come. So let's start off with talking about what I mean by flexibility via modularity. But before we do that, it's good to take a step back and look at the state of AI technology today. I like this quote that I largely adapted from Tom Galway that says, "We've not found an approach to AI capable of answering the questions that we don't yet know how to ask." I think that really hits the nail on the head in terms of just how far we still are away from artificial general intelligence. In its current state, we still primarily rely on supervised learning approaches that we've been using for many years. We're just doing that via neural networks that are capable of modeling more difficult to model relationships than ever before. And there's both pros and cons to this approach. On one end, the smaller, the more individual tasks that we attempt to solve, generally speaking, the easier it is to train a model for doing that, so less training resources needed, and it's also easier to measure the performance of that model. On the bad side, well, smaller tasks, that means the least it can do. So these types of models are usually pretty limited on what they're able to do outside of what they're trained to do. And then adding new models or traversing domains into different out of sample domains usually requires significant retraining, to be costly. And then on the ugly side of things, we essentially are unable to train any type of model where we're not able to create labels to model what we're looking for, right? So if you can't create a label that a model can learn from, so to speak, right, then you can't train a model for doing that. There's no label for rich context, so to speak. And you can see on the right-hand side, that's just a handful of potential tasks that we can train models over just for natural language processing. In general, when it comes to AI solutions, a single model is seldom really a solution, right? When we talk about training a single AI ML model today, we're usually talking about one very specific little task that's very domain specific. There's image classification, object detection, semantic segmentation. Those are all in the computer vision world. For an AI solution, though, we're typically trying to employ one or more AI models, ML models all at the same time, and we're trying to solve a variety of different use cases for a specific problem. And here you're going to see very domain specific and very vertical specific systems like those used for inventory management, fraud detection, predictive maintenance, right? So by using a workflow, we get to avoid some of this limitations of a single model only being able to solve a certain task, because we modularly able to combine models together to solve multitask at the same time, right? So even though it'd be a dream to have a single model that we could ask it to do any kind of question and it'd be able to do whatever we wanted to do, we're not there. And so until that time, taking individual models, putting them together, and then adding additional rules-based logic to customize what those models are doing and do other transformations, essentially, we're able to achieve a variety of different multitask, multifaceted problems that we weren't previously able to do. In addition to that, let's talk a little bit about some of the common AI deployment pitfalls that we see. Especially this pertains to people who are attempting to integrate AI technology into solutions for the first time, perhaps. And one common thing we see is attempting to cobble together some kind of solution with a number of disparate systems. Maybe I put a model here and host it there. Maybe I have this different type of model, I use this one, or I have this API from here, or this from that, all cobbled together into one thing together. And when we talk about productionizing really any type of solution, reliability and scalability are really critical. And every single one of the external dependencies that you introduce for a system, well, that just becomes another potential point of failure, right? It's also really common when you see these kind of distributed, cobbled together solutions, if you will, that it's difficult to achieve concurrency and parallel processing, okay? Every single touch point where we need to send data across some network, right? That's costly, the overhead. So what you commonly see is people waiting and batching things together and waiting till there's a certain amount together to send, or waiting till all the processes are done in a certain stage before sending to the other, versus having everything working in different branches parallel. Not only is there bottlenecks in terms of what you're able to implement from a synthesis perspective, but how you're able to implement it in the human perspective is also difficult, because you have these different siloed systems that all have to be maintained by different people. So what you'll typically see for an AI solution that's been developed is there's typically at minimum even 3 people that will be involved in the process to even just add a single new model to the existing solution. You'll see a data scientist who's the one who trained the model. He's going to have to go request somebody from the infrastructure side to go deploy that model. That person may or may not go tell the backend engineer, hey, that this new model is available. And then that backend engineer now has to figure out, wait, what was this thing supposed to do, and what's the type of output I'm going to be receiving, and how do I apply different types of logic to get the most out of it, to make it apply to whatever business results that we want, right? And so as every one of these systems is separately contained, and as they're highly specialized to what they're doing, that complexity breeds codependency, because it's very rare that you're going to find a single worker that's able to do all 3 parts all together. Ultimately, what we end up finding is, in these kinds of situations, it just takes a lot more time to do any kind of iterative changes. And in a space where experimentation really is everything, that leads to less experimentation, which gives you less chances to actually improve results. And so we see typically lower performance. So with using workflows, we are able to actually remove a lot of those bottlenecks by bringing all of that together, by putting the models that are immediately hostable on the same platform together and alongside each other with logic that can manipulate the outputs between them, right? And achieve a bunch of different tasks all within one workflow that's accessible with a single API call. Okay, so that's some of the common problems that we see. That's some of the reasons why we might use a workflow. What is a workflow, right? Well, from a technical perspective, sometimes we refer to the structure of our workflows as being a directed acyclic graph. Typically, that's kind of abbreviated as a DAG. And so the formal definition of a DAG is a structure comprised of a set of nodes and edges connecting one node to another. Great. What does that actually mean? Well, it starts with defining what a node is. And in different types of DAGs, nodes can be different things. In the Clarifai world, in our world, a node is a model, okay? And a model could be one of very many different model types, okay? But it's going to always just be a single model and a single node. And every single one of those models simply takes in an input and does some kind of function and gets some other kind of output. Okay. Generally speaking, the main constraint when you're putting together models into a workflow is ensuring that every single model that you put into the workflow can accept the output type of the node before it, right? So as long as the model downstream can accept whatever the model upstream is giving to it, then everything, for the most part, is going to work out. So that's the main thing to keep in mind whenever you're starting to compose your own workflows. And one of the main ways that we try to help break things apart, make it easier, because there's quite a few actually model types in the platform, is by using model types that are loosely connected to the input and output types profiles that they can operate over. But then they're also grouped largely by the major action that they can do. So we have groups of models, model types that can do filtering or editing, ones that can aggregate, ones that could do some particular action, typically something that triggers some kind of service outside the workflow. And then, of course, there's the main category, which comprises just about half of all of the model types in the platform, which is predict, anything where we're going to actually ask for some kind of inference. Inside of the workflow, we typically talk about there being certain control for flow and being able to control essentially what gets out of the workflow via outputs, okay? Outputs from the workflow themselves. A few common terms and then just ideas that are notable is that there's an idea that workflows are not just unidimensional, they're not just linear. Sometimes you might see different workflows and different systems that are just sequential and linear. And in our platform, they can branch. So we can go from one model and one output and send that output into two different nodes that start two different branches, okay? There's a variety of use cases for doing this. One is simply, I might just want to get predictions from a bunch of models all together, right? It's a convenience function so that I don't have to make multiple calls to different models over and over and over again. I can send it to one endpoint. It's going to get it from all the models at the same time and return that all to me. That's one example. That can be taken further though by using our filter, different types of filter model types here. Those are the ones here represented by blue. And these can actually do logical flow control where they can say, if it is not greater than or less than a certain value, in this example, a concept is not greater than or less than a certain value, then do not pass that output, that input down into the subsequent node. And then finally, you'll see there are controls for every single node for whether or not to suppress that node's output. And what do we mean by suppress? So you'll see there's a input nodes. This is where the input is coming from the actual workflow API that you sent to the workflow. You'll notice that there is no output node, and that is because by default, every single piece of data that's generated through this workflow is going to by default come to you in that output response. Okay. So if you don't want that to come to you and you want to potentially save on some of the network overhead and you want to make things a little bit more efficient, we make it easy for you to simply suppress that output. Now to note, it's important, that does not mean that it is not going to go to the next node in the workflow. It just means you're not going to see it. You don't want it to be returned to you in the response. Okay, how are we doing on time? I think we're okay. But that's always my famous last words. So let's look at first, before I go into the demo, there are a few pretty common workflow configurations. I don't really have time or scope to go through a lot of them. I decided to highlight a few of the three absolute most common that we see. The first one, I think I'll actually show you in the demo, putting that one together. We sometimes call this region classification or object recognition, different terms for it. Essentially, what are we going to do with region classification? We're going to say, where are the things located? Then we're going to do an edit where we're essentially going to create new images from all of the detected regions. So we're literally going to crop them out of the original image, and then we're going to pass those cropped images out to a third node, which is actually a classifier. So what types of the things generally did we locate, right? Object tracking, this just has two nodes generally, and this is typically works over video as an input, okay? And so given a sequence of frames, in every single frame, find all of the objects in them. And then when the model looks in the second stage, in between every single frame, which of the objects in the second frame did I actually see in the previous frame, right? Thereby being able to assign a unique identifier to each of the objects so that we can track objects over time. And the last one we usually call localized search. This one starts by saying, where are the things located? Then we do the same cropping function. And then the third is to say, okay, now that we have those, let's search some other source of input, some other repository of indexed inputs, and let's see what's the most similar things that we can find. Okay. All right. So now we will go ahead and see if the demo gods are in my favor. I think they might be. Okay, we are here in Portal. For those of you who don't know, this is the overview landing page for an application. I do not have enough time or scope to really give the full detail. I'm sure throughout the course of all the Perceive events, hopefully you will be knowledgeable of generally getting your working your way around in the platform. I'm going to go straight into model mode here and give you kind of the brief lay of the land, so to speak. Here you can see all the models that you have. This is actually all the ones that Clarifai provides. I can look at just the ones that I have here. And then we can do the same with workflows. I gotta move my little person here, a little view of myself. And I'm going to go up here and I'm gonna, by default, just try creating a brand new workflow. So when in doubt, you can always just create a blank workflow. There's two different viewer screens that you can actually go in, two different view modes. This is what we sometimes refer to as the linear workflow view editor. And my little guy is getting in my way again. We can switch to the visual graph mode, which is actually where we want to spend some time. I'm going to take a step back because there's a second way that you can actually accelerate things when you're building workflows. So one way was just create workflow and start creating one from scratch. There's another way where essentially any workflow that you already have, either one that I have, or you could actually look through Clarifai's as well, you can press this little button to copy to a new workflow. So this is a good little pro tip trick so that I can accelerate what I'm doing and not have to set everything up manually. For the record, if you did want to do that all from scratch, you absolutely could. By default, there's two ways to add nodes into a workflow graph. You can click and you can drag, and it will automatically connect it to whatever was previously selected. Or another pro tip, if you're really going fast and you know what you're doing, right? You can double click here and it'll automatically drop it in, connected to whatever was the last thing. So if I know if I want some particular thing to go after that one, double click. If I know what I want to go after that, double click. And sorry, I'm in a demo environment right now, but we will ignore that for now. Anyway, so this is, you're already looking at what we usually call a region classification workflow, okay? This is the typical formatting of it. And I generally advise when I talk about compose and customize, okay? What I mean is I usually advise people to think about the model types and laying those out first in order to achieve what they're trying to do. And then go in, and as you see, if you click on each of them, then you can customize the settings of each of those detectors individually, okay? So for example, if I wanted to just drag in some kind of other classifier that I wanted to do here, right? Maybe I want everything to go through this, and maybe I have some model that I want to use, right? And from here, I can choose the model that I want. I can choose the model version that I want to use. I can choose, like I said earlier, to suppress the output or not. And then as far as further output configuration, okay, I can set the max number of concepts. So it says I only want the top X, so top 20, for example, in this case, concepts returned, okay. I could select a specific grouping of concepts that I'd want in to be filtered before I pass it through, okay? And so each of these different model types are gonna have a different assortment of model type selections that you can choose. See, this one has a detection threshold that's separate. Any non-trainable model, okay, where it only has settings for it, you won't need to choose any kind of model or model version. You just drop it in, it has its own default settings by default, and you can choose some different setting if you want to here. Suppressing output here, like we talked about before. If I don't want this to go to the output, I can toggle that, okay? And so in this particular graph, we are taking a person detector, we're cropping that image out, okay? And then we're actually passing this one to our general classification model, which knows 10,000 different concepts. So this original model only knows one concept. And then we're detecting all of the people with it. And then we're passing that by the end to a classifier that knows 10,000 different concepts so that we can see if we can further classify each of the people. Essentially, if we can gather more information from each of those detected people, okay? So that's essentially it for how you set up workflows here. I am just gonna quickly show you one of the inputs here. So those of you who don't know, I moved over to what we usually call the Explorer mode, and then I clicked on a single input, and this is what we typically call the input details screen. And so here I can actually choose any of the model workflows that I have available. You can actually do that by choosing that right here. And I already have this people to general selected here. And so here, what you're going to see, remember I suppressed that output here. If I hadn't suppressed it, then you would see each of the individual people objects first, but I suppressed it so it's not coming through. And then down here at the general model, okay, you're seeing each of these detected people objects, and then we further got classification, got concepts for each of them, okay? So this particular one here was seen as a person, woman, adult, portrait, right? And we see other interesting information that's true. Eyewear, right? She's a purse, jacket, right? So this is a great way, once again, of extending beyond what a single model knows, right? Single model knowing how to tell you where the people is, cropping that out together to form a different image, which is needed for the downstream model, and then getting further information about the nature of that individual person object. So there we go. I only got a few minutes left here, so I'm gonna have to hustle up. I do want to leave you with just a brief glimpse into kind of what's going on behind the scenes. We are rapidly at work on workflow capabilities. I didn't even get a chance to touch on so many different capabilities that we have recently released with workflows. We're adding currently search into workflows so they can operate within them. We recently released workflow versions, and workflow evaluations are on the way immediately. And as we look out to the broader future, lots of things related to video, especially, and audio. And so with all that comes streaming. So we're working on being able to set up a workflow and then ask it to process a continuous stream of data, particularly in the cloud. And then you could use things like the action nodes to trigger events or store that output data into external stores. Common use cases are like anomaly detection, perimeter security, asset tracking, quality assurance. And then edge to cloud workflows, essentially running workflows in a distributed manner across models, running on connected edge devices and into the cloud. And then you could set up workflows that conditionally only pass the data to the cloud if certain things are present. And these are commonly seen for things like robotics, multi-camera tracking, often used in predictive maintenance, even drone swarming. So that is it. That's all I have time for. I want to thank everybody for joining me today on this session. This session will be available on demand in the next 24 hours or so. So stay tuned for that. It was absolutely a pleasure to have you here, and I hope you have fun on all the rest of the sessions for today. Thank you so much.